Alright guys, in lesson 3.9, we're going to talk about functions that can only be defined implicitly. So two things we're trying to accomplish in lesson 3.9. The first thing is to recognize that what makes a function be defined implicitly, and the second thing is how do you find the derivative of functions that are defined implicitly. Alright, so everything that we've done up to now is considered explicit functions. So like this is an example of an explicit function, and you've seen a lot of these. So what makes a function fall under a category of explicit or implicit? Well, a function is explicitly defined if the dependent variable, and that's the y variable, okay? So make sure you know that this is the dependent variable, can be written explicitly, okay, in terms of the independent variable, which is the variable x. So another way to think of this is explicit functions are functions where y can be isolated, because y is defined in terms of independent. So y can be isolated. That's what makes a function explicit. On the contrary, implicit functions are functions where the variable, the dependent variable, cannot be isolated. So a function in which the dependent variable is not isolated, as you can see, on one side of the equation. If you look carefully, this is the boundary that separates the left side from the right side. Notice that y is not isolated on the left side of the equation. In addition, y and x are actually together on the same side, so it's not isolated. And that's what makes a function implicitly defined, where the dependent variable, which is the y variable, cannot be isolated. Okay. All right. So typically, a popular implicitly defined function is the function of a circle. So this is the circle with a radius of 1. Here is another function which is implicitly defined. It's a circle with a radius of 2. See? Like that. And here's another one. Notice that y cannot be isolated, as you can see. Y is on the left side with x, and it's a very unique and different looking function. The graph goes like this, and then there's another piece over here, and it makes it really challenging. All right, so so now the fact that you know what implicitly defined function looks like, I'm gonna show you how to find its derivative. And remember that derivative relates to slope. And so when we find the derivative of this implicitly defined function, we're trying to find the slope function. And so before we move on, I just want you to point out a few things to you. Notice that when x equals to 0, the slope when x equals to 0 is 0. You're right, because this is a horizontal line. Okay. At 2, when x equals to 2, guess what the slope is? The slope is undefined. All right. So another way to find the slope is think of the slope at the point 0, 2. That's the point 0, 2 is 0. And the slope at the point 2, 0, that's the point 2, 0, is undefined. Okay, so keep that in mind, so that when we work out a few of these examples, you have these information to go with. All right, so let's do the first problem. Here it is: how to find the derivative of a function that is implicitly defined. So x squared plus y squared equals to 4. So to do this, I want you to follow these 3 steps. Okay, so the first step is take the derivative of both sides with respect to x. Okay, so here's what I mean by that. So this is the left side, okay, this is the right side. So we're gonna take the derivative of the left side and the right side with respect to x. All right. So when you take the derivative of the of this first term, you're gonna get 2x. When you take the derivative of this term, this you have to use the chain rule, and it's hard to look at this from the chain rule perspective. But when we take the derivative of y squared, okay, there is an outside function, which is this being raised to the second power, okay, and that there's an inside function, and that's the function y. All right, so you have to use the chain rule for this guy. Okay, so guess what you're gonna get? You're gonna get you have to do the derivative of the outside, which is 2, and then you leave whatever is inside alone, and then you multiply that with the derivative of the inside, which is y prime. Very good. And the derivative of a constant is 0. All right, now the next thing you do is you solve for y prime. And to solve for y prime, all we have to do is subtract 2x to both sides. That's the first step. And then the next step is to divide both sides by 2y. And if we divide both sides by 2y, we're gonna get negative 2x over 2y. So the derivative is negative x over y. All right, so that's the derivative function, and that will give us the derivative at any point on this graph if we know, if we plug in the order pair. So remember at this point, 0, 2, when you plug in 0 and 2, you get 0. Okay, remember this point over here where it's 2, 0? When you plug in 2, 0, you get undefined.